Hello and welcome to the solution of quiz number 1 of Calculus 1. The first question is find the limit of f of x as x approaches 2 if the function f is defined by the following. F of x equals to 1 if x is not equal to 0, and f of x equal to 0 if x equals to 2. Before we can say anything, let's take a look at the graph of the function. We have the horizontal line, the x-axis, and the vertical line, the y-axis, and we have the blue line. The blue line is the function. We can see from the blue line that the function's value equals to 1 everywhere except when x equals to 2. It's not equal. So what we can conclude is the following, that if we move x from the left towards 2, the limit will be equal to 1. And if we move x from the right all the way towards the value 2, we can see also the value of the function equal to 1. So we can conclude the following. Since the limit of the function as x approaches 2 from the left equals to the limit of the function as x approaches 2 from the right, and the limit, as I said, equal to 1. So we can conclude that the limit of the function as x approaches 2 is equal to 1. Next, evaluate the limit as x goes to 2 of x squared minus 10x minus 24 divided by absolute value of x minus 2. The limit of the first branch of the function as x goes to 2 is as follows. The same numerator, the only thing is no more absolute value. So the first branch is just x minus 2, and x minus 2 should always be positive. This implies the following, that the limit will be equal to, we replace for every x 2. So that will give us 4 minus 20 minus 24 in the numerator, and it will give us 0 in the denominator because we plug in 2 minus 2. So that will give us negative 40 divided by 0, and that's going to take us to negative infinity. For the second branch, the numerator is the same, so it remains the same, but the denominator will no longer be x minus 2, but will be negative of x minus 2. And if we do the math, this implies the same thing, which the limit, the numerator will be the same. That will give us negative 40. The denominator will give us negative 0, but there's no negative 0, so it's just like 0. So negative 40 divided by 0 is equal to negative infinity. So in both cases, the answer is negative infinity. Thus, we can conclude that the answer is negative infinity. Next, let f of x be defined by f of x equals to x squared minus 9 divided by x minus 3 if x is not equal to 3, and f of x equal to 6 if x equal to 3. Where, if anywhere, is the function f of x discontinuous? That's the question. Since the discontinuity at x equal to 3 is removable by the fact that f of 3 equal to 6, the conclusion is that the function is not discontinuous anywhere. Evaluate limit as theta goes to 0 of tan square of theta divided by 1 minus sec of theta. Since sine square of theta equals to 1 minus cosine square of theta, it follows that limit as theta goes to 0 of tan square of theta divided by 1 minus cosine of theta equals the following. Limit as theta goes to 0 of sine square of theta divided by cosine square of theta, which is replacing tan square of theta, and then in the denominator we will have 1 minus cosine theta, which is the same as we have here. All what we did is we replaced tan square theta by sine square of theta divided by cosine square of theta. Now we will take the limit of the next function, which is equivalent to this function. So this will be equal to limit as theta goes to 0 of sine square is equal to 1 minus cosine square of theta divided by cosine square of theta multiplied by 1 minus cosine theta. So we have on the top 1 minus cosine square of theta. We can factor this one out as follows. So it will be equal to limit as theta goes to 0. We factor the numerator. It will be 1 minus cosine theta multiplied by 1 plus cosine theta divided by cosine square theta multiplied by 1 minus cosine theta. We can see that we have 1 minus cosine theta in the denominator and 1 minus cosine theta in the numerator. So what we can do is we can cancel them out, and this is what we will be left with. We will be left with limit as theta goes to 0 of 1 plus cosine theta divided by cosine square of theta. But then if we plug in for theta 0, cosine of 0 is equal to 1. So we'll have 1 plus 1 in the numerator, and likewise cosine square of 0 is equal to 1. And that's going to give us 1 in the denominator. So the answer is 2 divided by 1, which is the answer that we're looking for. Next, what is the limit as x goes to 1 of the function 2 multiplied by 1 minus cosine x divided by x squared equal to? First, since cosine square of half x equals to cosine of x plus 1 divided by 2, this is from the halving of the cosine. This implies if we cross multiply by 2 and take the 1 on the other side, we will get cosine of x equal to twice cosine square of x divided by 2 minus 1. It then follows that limit as x goes to 1 of the function we are looking for its limit. The only difference here is that we color coded cosine x because we have an equivalent of cosine x. So we don't want cosine x, we want its equivalent. So the limit on the left hand side is the same as the limit on the right hand side. Like I said, the only difference is cosine, we replaced it by its equivalent on this side. So let's collect the terms. This one, we can take the limit as x goes to 1, and that's what we're going to get. So we replace every occurrence of x by 1. So that will give us twice 1 minus 2 cosine square of half minus 1 divided by 1. And that's equal to, we can collect this 1 along with this 1. So this is going to give us 2. So the right hand side will be twice, and then between parentheses 2 minus twice cosine square of 1/2 divided by 1, One more time, this one is added to this one, so there is no longer minus 1. So that is the left hand side is equivalent to the right hand side. Now we will go ahead and take the 2 outside as a common factor. So this will lead us to 4 multiplied by 1 minus cosine square of half divided by 1. But then we know that since there is a color code, that means these two are equal. And sure enough, 1 minus cosine square of half equal to sine square of half. So our limit will be equal to 4 sine square of half divided by 1, which is equal to 4 sine square of half. And that's the end of it. And good luck. See you in the next quiz.